All right, guys, this is gonna be the last video for chapter 11. We're gonna talk about tests for homogeneity and then tests for independence as well. There's still different forms of the same chi-square, just looking at different things, different sort of tests. So let's again start by some definitions here. So what is the chi-square test for homogeneity? Well, if you're gonna break down the word homogeneity a little bit, homo meaning compares the distribution one categorical variable with multiple levels to multiple populations and treatments. Think of Q sample Z, where you compare distribution of one categorical variable to two samples. Okay, it's kind of just an expansion on that. So we're going to be looking at one variable, but that could have multiple levels or multiple different treatments or multiple populations. You want to compare all those things together and see if they're independent or not. Okay, so now what's the test for homogeneity? Your HO is going to be that there is no difference in the distribution of a categorical variable for several different populations or treatments. So it doesn't matter, it's always going to be the same no matter what population you're in or what your treatment is. And your HA is then going to be different. There's going to be some difference. There is a difference in the distribution of a categorical variable for different population treatments. Okay. So how do we calculate this? What we're going to do is we're going to end up creating a little table, a two-way table. So to perform the test, we compare the observed counts in a two-way table, the counts that we would expect if HO is true. Your expected counts is going to equal your sample size times the p-value times the expected proportion if HO is true. You're just saying p essentially times p. So this is the same as the goodness of fit test. And again, do not round. And big thing here is not on the formula sheet. Okay, the conditions, the nice thing about this, the conditions are the same for test of homogeneity and goodness of fit. So we have randomization. N has to be less than or equal to 1/10 big N. And 3, you have all expected counts greater than 5. So that's where that comes from. What's the equation? Okay, nice thing here is that same as the goodness of fit. So you have chi-square equals observed OBS minus expected quantity squared all over the expected value. And then you got to take the sum of all those. Then you take the sum. Okay. And again, this is on your formula sheet. Okay, the part that changes is the degrees of freedom. That's the part that you got to be careful of. So you got to know what you're looking at here. So here, degrees of freedom. This is the part that changes. And so when you look at that two-way table, what you're going to do is you're going to do your number of rows minus 1 times the number of columns minus 1. So degrees of freedom is going to equal number of rows minus 1 times the number of columns minus 1. Okay, and then on your chi-square table, I didn't mention this before, but the p-value is to the right of the chi-square, that in the chi-square distribution. Like I said before, you can use your calculator, but again, we're going to do this whole state plan, do, conclude. We've done that loads of times. So here, try it out with this problem, see if you can do the whole thing. And again, we'll go over it in class. And we'll talk about the follow-up analysis too. Okay. A lot of good practice here. So again, I'm going to skip these two. Really good practice. See if you can kind of do these problems on your own, and we'll go over them in class. Okay, so I'm going to skip down to what is the chi-square test for independence. So what does it mean for two variables to have an association? What does it mean for two variables to be independent? How do you state the null and alternate hypothesis? So first thing is the probability of one has an impact on the probability of the other, right? So what the independence kind of, the definition of independence, right? So I've talked about this before. It's kind of like your changes your feelings. If knowing one thing makes you change your feelings about the next, then that's going to be dependent. And so this is like go back to chapter 4. Independence and conditional probabilities. And so your HO is going to be that there is no association, therefore independent, and your HA is going to be there is no association. So how is the chi-square test for independence and the test for homogeneity different? So they both start with a two-way table. If there's one sample and two variables, we are testing for an association between the two things. If there are two or more, so 2 plus samples or groups, but only one variable, we are testing homogeneity. It is all about the way the data is gathered. Okay, so this is the hard thing about these is that you're going to have to really be careful about how you read the problem because that's going to tell you what kind of test we're going to be doing. Okay. Now this is where some things change up a little bit. So we're going to write some equations here. How do you calculate the expected counts? The expected counts is going to equal your row times your column divided by the table total. So EXP is going to equal row total times column total all over the table total, so the whole total. Okay, and you need to do this for each cell. And then what's the actual chi-square? It's the same as always. So chi-square, go to the sum of the observed minus the expected, all squared, divided by expected. So that part doesn't change. Conditions don't change either, which is nice. So you still have random. You still have n has to be less than or equal to 1/10 big N. And then you also have all expected counts need to be larger than 5. And again, the hardest thing, or the most, not necessarily the hardest thing, but the thing that's going to take the most amount of time is going to be finding the expected counts. So for example, here on this next one here, to find the expected counts, what you're going to have to do is do, for this first cell, if I'm looking at this first cell here, this very first cell here, what I'm going to have to do is do row total, 158, times column total, so 158 times 227 divided by 460. Okay. If I go to the next cell, I'm going to need to go, so if I'm looking at this cell, I'm going to go 86 times 227 divided by 460. Right. I'm going to do that for every single one, right? And that's going to be my expected counts for this whole table. And then I can go ahead and calculate my chi-square using this. Right. So that's kind of the idea. Is this? It's going to take a little bit longer, but try it out, see how you do. Again, we'll go over in class. That's kind of the idea behind it. Okay. So the thing with chi-square that you got to be careful about is there's certain ways in which chi-square is not going to be appropriate. And I'm going to talk about this in class because I want to spend some time and so you guys can ask questions on it. So this last problem we'll do together in class. But you have to be careful when using chi-square. There's certain scenarios where it's not going to be appropriate to use it. Certain scenarios where it will be appropriate. So, and then how to tell the difference between independence and homogeneity. That'll be a good wrap up to this unit. So we'll talk about that in class. But as always, guys, that's the end of this video. If you have questions, please let me know. We'll go through some of the questions in detail during class. But have a great rest of your day.